Sir. Bani, sir. Prashant, bani. Vikram. Desa bani, sir. Prashant, sir. Desa bani. Bani, sir.
Prashant.
I now request our Dean Academic Professor Sridhar sir to give the inaugural speech.
Good morning, one and all. Respected Head of the Department, Dr. Sudhir Reddy, Professor Mukundan, Professor P.B. Shetty, and our Administrator, and all respected faculty members of our Mechanical Engineering Department of NMIT. I am today very happy to be the a chief guest for this function to inaugurate the training program sponsored by AICTE. This training program, Drivers of Industry 4.0. This is the third training program in the series sponsored by NMIT. Already two programs were conducted. One is Industry IoT and another one is Overview of Industry 4.0. For these two programs, we got tremendous response from the faculty members all over India, where in the first program we got more than 800 registration. In the second program, we got 1000 plus registration. In the third program, now also we got more registration, but due to the academic curriculum, beginning of the academic curriculum, some of the faculty members are involved in the academic activities, therefore they could not join this program, and they need our program, recorded program later for the purpose of understanding the content of this very important topic, Drivers of Industry 4.0. This Mechanical Engineering Department, our institution, in one of the major department and also premier department, where we have got more energetic faculty members, dynamic faculty members, who always wants to be active even in this pandemic situation also. They successfully conducted two short-term programs, and also there are series of programs are there till the next academic year, 2021, and they have got programs sponsored by the VTU, Visheshwara Technological University, now the AICTE, and after the completion of this, after next month, they are going to start another program sponsored by this ISTE and AICTE. This is a very important program. Our Nitte Meenakshi Institute of Technology is an autonomous institution, a premier institution in the country, where it has been accredited by the NAC as well as the NBA under the NBA and Tier 1 status. We have got a accreditation under the Tier 1 status from the NAC. We got recently A plus grade. And we have got 5 UG programs are all accredited, and the college has been accredited by NAC with the highest A plus grade recently, and we have got highest marks in this. Now, in a short duration, even though institution has been established in 2000, within a short period, only in the when it was 6 years old, we got autonomous status. The first institution, engineering institution, got accredited, got autonomous status in a very short period within a span of 6 years in the country. The Department of Mechanical Engineering, they started in the year 2002 with an intake of 60. Later on, it has grown in such a fashion that the demand and also the strength of the mechanical engineering department made this to attract the students, and it has been increased. The intake has been increased from 120. Now the intake is 180. We have got a PG program also, that is the machine design. They are successfully running. The mechanical engineering department, now this drivers of industry 4.0 has been tuned itself to accommodate the drivers of industry 4.0, the topic. The faculty members have been trained and our infrastructure has been enhanced and our laboratories are equipped to train our student in this industry 4.0, because this industry 4.0 where the drivers are the augmented reality, system integration, cloud computing, big data, IoT, 3D printing, cyber security, autonomous robotics, simulation, all these things. These subjects, these areas are all interdisciplinary, and it is moving away from the core. That means keeping the core in into as a mainstream. Our faculty members are training the student in this area where the next decade, after 2020 to 2030, particularly in India, is driven by the industry 4.0, where we have to get equipped with all this knowledge and also the technology. Therefore, this is an opportunity for our faculty members to know about each and every aspect. Even the duration of 5 days, that is October 19 to 23rd, is very short to understand these topics, because these topics are all are interdisciplinary topics where we are dealing with the sensors, we are dealing with the what you call it, softwares, artificial intelligence, machine learning, in the Internet of Things, and drones, everything. Therefore, the technology is high, time is very short. Therefore, within the small duration, the small time, only for the 5 days, we had to put all the information. Therefore, the department has identified very what you call a knowledgeable expert to deliver the talk on this topics. That is, these are called drivers. Therefore, the industry people, they have accepted our invitation. They are coming, they are handling the classes, the lecture, and also sometimes they are giving the virtual hands-on exposure on some of the software tools to be used in this particular area. Therefore, I request all the faculty members who are registered for this to make use of this facility. This is a very important facility. Even the time is very short, they can understand, and this is the beginning of that. Therefore, all the information will be given by the industry expert, and I sincerely request the faculty members and the participant to understand this, to make use of this, and the timing is 10 a.m. to 11:30 a.m. and 2 p.m. to 3:30 a.m. Therefore, within this short duration, it will not they can make use of this in a short duration, and sufficient time is given to think and to analyze and to participate in this program. I again request all the faculty members and participants to make use of this facility. I appreciate the mechanical engineering department for making this program, that is what you call drivers of industry 4.0, to be presented to our faculty members, not only for NMIT faculty, to all the faculty members of India. And this is a good attempt by our mechanical engineering department. I congratulate and appreciate the interest shown by the faculty members and also the head of the department to bringing the good people, knowledgeable people for this. I again request the faculty members and participants to be involved in this 5 days program without any absent. Therefore, I once again wish all the success for this program, and also I again wish the department will arrange more and more good programs to encourage our young faculty members. Thank you very much.
Thank you so much, Dean sir, for your inaugural speech and excellent support that you are providing to us. I now request the executives and the resource persons from SPICET to please take over the session.
Hi, good morning.
Good morning, sir.
Can you see my screen? Is my screen visible to all of you?
Yeah, now it is visible.
Okay. So, good morning. Warm greetings from SPICET. On behalf of SPICET, I would like to welcome each one of you to today's session. Our vision at SPICET is to connect academia with industry by bringing in industry experts to impart their knowledge with the others. Our session for the day will be on diving into artificial intelligence and machine learning. The session will be delivered by Mr. Umang Sharma, who works for one of the big four firms in consulting. Umang is a data scientist and an author of an upcoming book on AI and deep learning. He is also an official speaker of Google's machine learning crash course in India, an open source contributor to Google Colab, and advises Fortune 500 clients on AI and machine learning solutions. Thank you, Mr. Umang, for accepting our invite. The duration of today's session will be 90 minutes, including the Q&A session. So we request all of you to please mute your mics to avoid interferences. You can type in your queries in the chat box and we will answer it during the Q&A session. Once again, we thank you for your time and we believe that this session will be useful to you. Over to Mr. Umang.
Thank you, Arvind, for the warm welcome and this mini introduction of mine. Can you guys hear me?
Yeah, we can hear you, sir.
Yes, sir. Yes, sir.
Yes,
sir. Hearing.
Yeah, awesome. Let me start presenting my screen. Let me know once my screen is visible, okay? Can you guys see my screen?
Yes, sir. Yes, sir.
All right, let's get started. Good morning, everyone. My name is Umang Sharma. I'm a data scientist. I'm an author of an AI book. As has been mentioned, I'll be delivering this session on AI today, and I'll try to make it as less technical and more in mechanical and industry standpoint. I know most of you are from the mechanical department, so I'll try to connect all the concepts of AI, artificial intelligence, with Industry 4.0. And I hope hope all of you learn a lot today and have a lot of fun as well. If you have any question, please comment that in the chat box, and we'll be happy to take that. Let's get started. All right. So first of all, the very buzzword is artificial intelligence. We have been listening about this word for so long these days. Everyone has been talking about it. Let's see what is it. So artificial intelligence or AI, it is the current highest, most trending technology of 21st century right now that we are dealing with. It majorly helps in three things. It reduces the time coding the rules. That okay, you have the rules. You at times you don't have to. If you have to code, you don't have to really give a lot of rules to the machine. I'll give you an example. There was a company in 1980 who wanted to build a transfer translation machine. Okay, so they wanted to convert French words, French language into English language. Okay, something like Google Translate. They tried that in 1980. But the issue these people were facing, so what they did, let me tell you what they did. So they tried to actually encode all the hard code, all the rules that are possible. Okay, so for example, the should always have something behind after it, and a and should be before a vowel. A should not be before a vowel, etc., etc. So they spent a lot of time. So they spent around 3 years writing these rules in the language. So they encoded all these rules in the language. Okay, but when they tried to test that machine of this translation from French to English, even though they tried spent 3 years encoding this particular set of rules, the machine failed. Why? Because like there is impossible. It's not possible to encode all the rules. Even though they spent 3 years coding these rules, what happened is that the moment someone actually input a French sentence which was out of their rules, which were against their rules, the machine failed because it was just accepting the rules only coded, and it's not possible to encode all the rules, right? That language is such a thing that anyone can say anything, and if it's grammatically correct, you can make impossible number of sentences for a given expression, right? So the whole idea of artificial intelligence is to make sure that you don't have to code the rules. There is a way we have these algorithms that allow us to. You don't have to code the rules. You don't have to code it. If you hard code the rules, then AI is not required. So I'll come to it, what it means, what is rules and everything. But we know what are rules, right? But how do we do not encode the, we don't have to code the rules in AI, it reduces the time. That's the first help it does. Secondly, the error rates are very low compared to humans, right? So for a given task, right? A given task like identifying people, right? Like you have a camera set up in your computer or anywhere in your room, and it's counting the number of people in the room, right? It's a task a human can do, but it's possible that humans are error prone, right? Humans can do errors as well. Humans do error all the time. Human errors are everywhere. So but if a machine is trained to do that, the error rates are very less. So that's how AI helps, right, in industries as well. That for a given task, the industry, for a given task in industry, the error rates are pretty low for AI in compared to humans. And then after all, third point. So we all know, right? Even though we are all from mechanical department, we know, right? Coding takes some time. You have to write a logic. You have to do basic coding, right? And coding is everywhere. You cannot imagine a life without coding in industry these days, right? So coding is everywhere. But a lot of problems are there which cannot just be solved by just coding. You have to do other steps sometimes with that as well. So that's where AI comes up. So these are the things that wow, what is AI? What is AI? And kind of very very high level introduction. As we move ahead in this session, we'll know more about this. Okay. All right. So let's see what is the difference between traditional programming and machine learning, right? So traditional programming, right? It could mean any traditional program. I think in first year, all of us in engineering, that all of us who have gone through engineering or are engineering right now, in the first year, we all have to learn something called C language, right? A language would be there. It would be C or C++, depends, but we all have one programming course in the first year, right? So we understand the basic programming, right? So programming is simple. Basic programming, the traditional programming is simple. There's a computer, you give it data, and you give it a program. Program is nothing but a set of instructions, right? So let's say if you are writing a program to calculate the average of given numbers, it's simple, right? So you write a logic for calculating the average, then you give it some data, you will give it some list of numbers or an array or anything, you give it a list, you give it the date, you give the computer a program, a logic, a data, and then you have the output. Then your programming, your output is coming. That's a traditional programming. It's simple, right? Data, program is set of rules, set of output is there. But machine learning is different from that. In machine learning, you don't give the logic, you don't give the rules, you don't give the set of instructions to the computer. As I said, the rules, right? The set of instructions that A plus B is equal to C, You have to calculate the average. You sum them all. You divide by number of observations. That's how you get the average. Those were the rules. That's what's you in traditional programming. In AI or in machine learning, that's not the case. The data is given, okay, this is my data, and you tell that, okay, with this data, this is the output. You know what? If I give this list of number, this is the output. If I give you this list of number, this is the output. If I give you this list of number, this is the output. Now you figure out what's the logic behind it. Now you figure out what's the rule. You don't know what's the instruction. I'm not giving any rules to AI. If you have to give rules, that's not AI first of all. So no rules is AI. You cannot just, you can't give rules. That's the rule. That's the first thing to understand in AI. Where there is rules, you don't need AI. Okay? So that's the first thing to understand. That in AI you don't give the instructions to the computer. You just give the data, you give the output, and the program, the logic, everything will be taken care by the computer. That's how AI is done. That's the basic building block of AI. Okay, let's move on. So that's the first thing that we understand, that AI is totally different from traditional programming. That's the first thing we need to understand. It doesn't. You have to have a lot of data to give to computer and the output. Then only AI would work. Okay, that's the first thing we need to understand. Moving on, the difference. Okay, so in traditional programming, we use assertions to prove our program is correct. When I say what is assertion, it's simple, right? That if I give it three numbers like 1, 2, 3, the average would be 5.5, right? So 3 plus 2 plus 1, 6, and divided by 3, it would be 2. Sorry, yeah, it would be 2, not 3.5. It would be 2, right? So 6 divided by 3, that would be 2. Okay, that's how the average is. So that's my assertion, right? That if I hear some disturbance, guys, please. If you're not talking, can you please go on mute? Okay, this is better now. Thanks. All right. So we use assertions to prove our program is correct. That's the first thing, that okay, if I give three numbers to my average program, my program which is has to calculate the average, it would be 3 plus 2 plus 1 divided by 3. That would be 3. 2, sorry, that would be 2. So I know the average would come to. I know it will correct. In AI, it's not the case. In AI, you cannot assert that the answer will be this only, because you use statistics and not logic to analyze the results. There is no logic like there is. You cannot directly say that okay, if I do this will happen. No, we use statistics. We say that okay, if I do this, hey, there's a 90% chance AI would give me this answer. There's a 95% chance AI would give me this answer. It's not always 100%. It cannot be 100%. AI is based on statistics and probability. That's another interesting thing to know. So you don't have to code the rules. You cannot code the rules. If you have to code the rules, that's not AI, that's traditional programming. You have to give it a lot of data. Second point. Third point, we use statistics and not logic to analyze the results. It's statistics. It's also probability that okay, if I give it this particular input, there's a 95% chance AI will give me this particular output. That's how it works with AI. Okay? All right. So that's the idea. That's the very basic idea of AI and if versus the traditional program. Let's move and understand how this could be implemented the industry side. Okay, how you can do it in industry, and where exactly you think industry can fit in this, and etc. etc. Okay. First of all, let's discuss about evolution of industry. Okay. So industry, when we say industry, we're talking about manufacturing industry. This is the one particular industry that has been there for forever, right? It's been there since before ages, right? Before World War as well, right? And even before, not even before World War, it's the industry, the manufacturing industry has been there for even before that, right? The steam engines and everything. So currently we are industry 4.0, but what are the other areas of industries that the versions that have been there before? Let's talk about that. So first breakthrough or the first starting of the industry was industry 1.2. When James Watt actually discovered the steam engine and everything, the steam power actually started to come. The whole idea was to basically mechanicalize all the simple tasks, right? So for example, a weaving machine, a steam power engine, using steam to actually drive a train. So, and basically the idea was to mechanize everything. So, for example, the gears and levers, right? All these things are stuff that are made to ease your task of doing something, automating it without using any electric power right now. So we don't use any electric power in Industry 1.2. It's basic mechanic, it's basic automation using the tools. So gears, chains, steam engine, and then your weaving loom, your sewing machine, all these were part of Industry 1.2, the very beginning of the industry, right? Automation using simple machines, using automation using simple machines. Then came Industry 2.2. Industry 2.2 was the time when Henry Ford actually started the process of mass production, assembly line, the concept of assembly line. That okay, there is an assembly line, there is a worker standing there, and everyone has got a single job to do. Every worker has to do a single job for the rest of the day. There is a guy whose job is to actually this first of all, there is a line going on, right? We all see how cars are produced, right? The assembly line, the mass production. So there is an assembly line which is moving in forward direction. There are people standing in the workers are standing on the line, and every worker has its one task to do, one job to do every day, right? That was the Industry 2.0, mass production, right? This way, people could produce so many things. The Ford cars were produced this way. Assembly lines were made on this way. Everyone is doing their single job. The line is going, and we were able to produce so many stuff using automation. The Industry 2.0 was a breakthrough. Then there is also the concept of electrical energy came. People were using electrical energy, the motors to move the assembly line. So electricity was there in this Industry 2.0. The electricity was there, and we were able to automate a lot of stuff. Okay. So that was Industry 2.2, right? Automation using electrical energy, assembly line, mass production. So lot of money for the rich people, right? They were able to automate so many stuff. Then came Industry 3.2, which wasn't very long ago. Industry 3.2 was the time when industry started to use computers for their services. So basic stuff, right? Computers automation, ERP, using robots. That was Industry 3.2, using electronics, basic electronics, right? They were using basic electronics, lights, LEDs, automations, computer to automate a machine. Now the assembly line is run by a computer. People were able to monitor their machines via computer. People were able to check the machine via computer. So Industry 3.2 is automation via computers. Industry 3.0 is where the computer started to come in industry. Before that, there were no computers. So automation using computers, electronics, circuit building, circuits, they were using everything, electronics, lights, LEDs, automations. Then came Industry 4.0, where we are right now, where what we are discussing this right. Just a minute. Sure. Thank you. All right. Then came the Industry 4.0, where we are right now. So Industry 4.0, if you listen to some people, they say that came Industry 4.0, where 3.0, which is partially correct. Yes, because the computers were introduced in 3.0. Then Industry 4.0 is where we still using computers, but now some interesting things or concepts are getting used. What are these? Physical systems, IoT, network, AI, all of that is a part of Industry 4.0. So what's happening now is that even though we are using computers, but now we are going next level of it. Now we are using AI in 3.0. Now we are using robotics in Industry 4.0. Now we are using cyber physical systems. What are cyber physical systems? They are literally the computer systems that are talking to each other via networks. So these things, the networks, the IoT, the AI, the robotics, all of this is Industry 4.0. This is where we are right now. All of that is a part of Industry 4.0. Technology. What's happening much more than computers in Industry 4.0. That's where we are right now. And all of this whole program that is being run by this NMIT college will only cover Industry 4.0. Today's session will be on AI. It's on AI, but we will be trying to connect this with industry so that we are able to connect industry and this AI together, and we will learn how AI is currently applied to industries, how it will be applied in future, what all the steps, etc., etc. So we'll learn everything about AI in context of industry today. Okay, let's move on. First of all, where not to do AI. Before I tell you how AI works, let's see where not to do AI. Okay, because now we will talking about how do we use in industry. Let's see where not to do AI. First of all, the first thing to keep in mind is that if you need to fix rules, right? I've been speaking about rules since the last all the slides. If you have to fix any rule anywhere, okay, if there is a concept of rule that 2 plus 2 is equal to 4, or if I press this button this should happen, if I press that button this should happen, if there is a one-to-one fixed rule, no, you should not be using AI. You don't need AI there. A simple traditional programming, a simple program can solve your problem. I'll give you an example. A manufacturing client came to me once and said, you know what, I have this process that if I press this button, my machine should start and I should see the output of the machine on my screen. Do you think I can do AI here? I said, no, you cannot. You first of all, you don't need AI for this. You just have to press a button and you want to start the machine and see the output on the screen. That's a rule right there, right? You don't really have to use AI for this. AI comes when you have to automate, which cannot be fixed by rules. You can fix a rule here, right? So you don't need AI here. When you can fix a rule, when you can, first question to ask yourself is, hey, can I fix a rule here? If you can fix a rule here, you're good. You don't really need to do the AI at all. All right. If there's a problem where you fix the rule, that's where AI comes. Let me give you an example. So then another client came to me and said, you know what, Umang, I have this machine which is producing tablets. Okay. A lot of medical tablets are getting produced in my machine. And I have this giant bucket where all the tablets get stored. Okay. Now I want to know that whenever this the bucket where tablets are filled, whenever this tablets machine, sorry, whenever this bucket get filled, whenever the tablets are up to the limit of the bucket, I want to make sure the machine that's producing the tablet should be closed, right? So now here I cannot set the rule because how will the machine know the bucket is filled, right? There is no direct way of knowing the bucket is filled. I use AI here. I put up a camera above this machine where the above this bucket, which is getting filled by the tablets. The moment the bucket is filled, AI, the camera in the camera takes a picture continuously, takes a video stream. The moment bucket is filled, the AI works and tells, okay, the bucket is filled right now, stop the machine. You see what's happening? Here you cannot fix the rule. Here there is no rule to tell when the bucket is filled, right? Until and unless you actually stand a human person there and a human looks at the bucket and sees, okay, now the bucket is filled, I should stop the machine. There is no other way. There is no traditional programming cannot solve this problem. A traditional program cannot just see the bucket is filled or now. You have to have a camera, then you have to put a program, a AI, you have to put a AI application in that, and AI will read it and see that, okay, the bucket is filled now, okay, stop the machine now. So that's the first thing. So there's the two examples, right? When you can fix the rules and when you cannot fix the rules. In first problem, when you have to just press a button to run the machine and see the output, you can fix the rules. But when there is an issue like this, when you cannot fix the rules, there is no way of the computer to know that the bucket is filled, you have to use AI. You cannot fix a rule there. First thing. Second, if the data is not in good volume, very important. If the data is not in good volume, you don't have enough data, you cannot use AI. First of all, that's very important. You cannot use AI where data is not in good volume. If you have less data, the data is not important, it's not in good volume, you cannot use AI. When I say data, it could mean anything. If I'm talking about the second example that I was taking a while back, an example about this one, the bucket getting filled. If I don't have enough data of the images of the bucket or the live video feed of the bucket, I don't have enough data to train my AI. AI won't work. So a lot of enough data. Third point, very important, that AI projects have a slight risk of failure. It's not always 100% the AI project will work. They have a slight risk of failure. So it's important that you understand that if you cannot take the risk, if you cannot afford to take the risk of failure, then there is no point of using AI. Okay, so make sure that you understand the risk behind AI projects. They are prone to risk. Fourth and very important is that you don't have dollars to burn. It's very important. AI takes a lot of money to build in industry level, obviously. It takes a lot of money to build. You have to have data scientists, you have to have AI engineers, you have to have data engineers. There are lots of teams, we'll come to it, that need to be there for it to make AI for you. So you have to spend a lot of money. So if you don't have enough dollars to burn, you should not be doing AI. So that's the first four basic principles that where not to do AI. Okay. Moving on, let's discuss. Now we are actually building our base to learn what is AI and everything. Okay, let's move on. What makes AI work, right? So what makes AI work is carefully crafted statistical algorithms. So I said that AI is all statistics. First of all, they are very carefully crafted statistical algorithms. So the idea behind AI is that you give enough data and you tell what's the meaning of this data. Okay, let me give an example. Okay, of the bucket example, the industry example only. The bucket that is getting filled by the tablets, right? So that's, let's say, the images of the bucket is my data. Okay, so I take like maybe 1,000 images of the filled bucket. Okay, filled bucket. I take 1,000 images of the filled bucket, and I take those images and I tell that, okay, this is the filled. Okay, I tag them, the bucket, the photo image one, filled bucket. I call it filled. Okay, the other bucket in filled bucket, I tag the filled again. So I have 1,000 images of the filled bucket, and I give them a tag of filled buckets. Okay, I know that. I give this data of images with their filled bucket tags to the AI algorithm. Okay, now the statistical and mathematical algorithms will learn these patterns. Okay, that's how AI works. They will learn these patterns. Okay, I have the bucket. I have this image of bucket which is filled. I know the tag is there. The output is filled. I know that's the area. Okay, let the machine, the algorithm, the statistical and mathematical algorithm, it will learn. That's why it's called machine learning. It will identify these patterns in the data. If I see this image again, it would mean this is a filled bucket. Okay, if I don't see the same image which is filled, if I see partially filled or half filled, I won't call this as a filled. So the AI, the statistical algorithms, the mathematics will try to identify these patterns behind the data. Mathematical equations, they are bound together to learn these patterns, and we give them the enough data to learn these patterns. That's how AI works, guys. Very basic idea behind AI. Data, images, output, filled, everything, all of this bucket is filled. All of these images means these are filled buckets. Then we give this to the computer. Computer has a statistical and mathematical algorithm, a mathematical equation running behind, which will learn this pattern, which will identify that, okay, if I this is my image, what is the meaning of this, and it will learn this pattern, and it will use this data to learn the patterns. Okay, that's how AI works, folks. That's how AI folks works. That's how it all works everywhere in the world. Basic idea behind AI. Okay. But let's discuss about this very, very important concept. Okay, then there is a concept. Now there's a lot of words, right? Nowadays you hear a lot of words, right? So AI versus ML versus data science, deep learning, big data analytics, and whatnot. Lot of terms, right? So what divides them? What's the difference between these ones? Let's see. So AI is the broader concept which is encapsulating all of them, which is covering all of these smaller concepts. So artificial intelligence is the concept, is the idea that is giving the capability to machines to perform tasks which were easily doable by humans, but now the machines are able to perform those tasks. That's AI. Machine learning is one such way of doing AI. Okay, there are other ways of doing this as well. Robotics is an AI, for example. IoT can also be an AI. It's not always an AI, but it can also be an AI. Okay, so machine learning is a form of AI. AI is the head concept. It's the principal. It's the dean of this department. Machine learning is one such one such small department in AI. Okay, and then data science. Data science is basically using machine learning. Okay, let's talk deep learning and big data first. Okay, then we'll come to data science. Deep learning is another way of doing machine learning. Deep learning is next level of machine learning. It's even better. It's more complex than machine learning. It's even deeper than machine learning. That's deep learning. Okay. Then there is big data. Big data is the concept which is the backbone of AI and machine learning. We need a lot of data. I said right in a slide ago that we need a lot of data to train, to actually make AI work, right? But how do I store this data? How do I process this data? There's a concept called big data, which is basically nothing but storing huge volumes of data and able to process it faster and faster because we have so much data to understand. Process it faster, we use big data. Okay, and using all these concepts of machine learning, big data to actually solve problems, business problems using data, it's called data science. The science, the technology of using big data, deep learning, machine learning together to solve business problems, to solve the problems, it's called data science. Okay, using data to and science for the problem, that's why it's called data science. Okay, scientific science is your machine learning, data is your big data. Using them all together is data science. All right, let me give you a formal definition of as well, right? Of data science versus machine learning versus data AI. Okay, so AI is the ability of a computer or computer controlled robot to perform tasks commonly associated with intelligent beings. Okay, so as I said, AI is the capability to do tasks for a robot or a machine to actually perform tasks which are associated with humans, right? With what intelligent people can do, now machine can also do. Machine learning is a type of AI that you are allowing software applications to become more accurate at predicting outcomes without being. So you are not giving a program. Okay, you are not giving a rule to it. Now machine learning is a type of AI, is a type of science that allows the machine to understand these patterns that I discussed earlier and understand what's happening and then give predictions out of it. Data science is an interdisciplinary field that uses scientific methods. So data science is a field interdisciplinary. It uses machine learning, AI, deep learning, big data, etc., etc., scientific methods, algorithms. Doing them all together to actually solve problems is called data science. Okay. All right. That was AI versus machine learning versus data science, guys. But now the question that comes is, okay, how can I apply it to my business? I mean, when I say my business, and I mean the industry, right? It's very important, right? As mechanical engineers or as people who have their own mechanical industry, they ask me these questions, right? That's the question that everyone gets, that how can I apply it to my business? First of all, define the problem well. Very, very important. You need to define the problem very well. That's the first thing to understand, that if the problem is not defined clearly, that's the issue that comes with most of the people these days, most of the industries, that they are not able to define the problem correctly, which is not correct, which is not good. You have to define the problem well. You have to tell me, or you have to tell your AI expert that this is the problem I want to solve. How can you help me in this? Very important. If you can tell the problem that you need to solve, then only you can move ahead with this. If the problem is not clearly defined, your AI won't work if the problem is not correct. Okay. Every business has some problems which could be solved by ML. Yes, that's very correct. Every business has some or the other problem which can be automated and solved via machine learning, can be solved via AI. So very important. Okay. Start with answering few very, very basic questions. Okay. That okay, if do I have the enough data? Do I define the problem well? Do I have the capability to take the risk of AI? Do I have the enough money to burn these dollars? So all these things are very, very important. Okay, so you should be able to define your problem well, and you should answer these basic questions that I discussed in some slides ago. And then obviously possibilities are endless. As I said, every business has a lot and lot of capabilities to do AI, and the possibility to do this are endless. There are so many possibilities to apply AI in every business, no matter what your business is, no matter you are a cycle shop, you are a milk industry, you have an industry that prepares shoes. Every industry has a possibility of applying AI and ML, and that's for a fact. Okay, very important. Now let's now discuss the. This is a very important slide, a very important infographic by McKinsey and Company. Okay. Now the idea is that how AI is applied to the business, and there are so many things to understand in this particular graph. So for our development vertical raw mile, that's a very consulting type of terminology. Let me break down to very simple terms. Let's start from the basics, the leftmost bar, okay, the manual bar. This is where most of the industries are. Okay, so the gain, when I say the gain, is that the, let's say the 98.9 is the, let's say that's the profit of an industry. Okay, let's see it that way. Okay, that's the profit of the industry. So currently that's the capacity of the industry, let's say. So that's the number. If the number goes up, your industry is doing good. Okay, so at the manual you are at 98.9. Your industry is totally manual right now. I mean, you are just doing manually right now everything. Let me give an example. Actually, it's better to do with an example. Let's say there's an industry that is making cycles right now. Okay, everything is happening manually right now. So they get all the parts of the bicycle. They get the tire, the chain, the pedal, the handle, and everything. Okay, and they are at this stage right now. They are at the leftmost stage right now. They are very manual right now, and their hard that feed rate for our development is 98.9. I mean, for depend, they are not going that great right now. They have the potential to go more than that, but they are at 98.9 right now. Second step comes. So now they say that, you know what, let's not do it manually. Let's actually let's not do it manually. Let's upgrade our hardware. Okay, let's do some things in an automated fashion. So, putting the tires into the bicycle and putting the chain into the bicycle, putting the handles into the bicycle. Let's automate these particular steps. Okay, that's the step one. So let's do the hardware upgrade. Now they're at 107.1. That's an 8.2% increase in their hardware, in their feed rate. That's a good rate, right? That's 8.2% in their profit also. That directly connects to profit. Okay. Now, now someone says, you know what? You, even though you got the hardware upgraded, let's actually upgrade. Let's automate everything. Okay. Now let's, even there were few steps that's happening manually. Let's update all of them now. So now let's just upgrade all the machines. Let's upgrade your chain putting machines, your tire filling machines. Now whole of this thing is upgraded. Now everything is automated in the industry now. No manual stuff, nothing at all. Now we are at step two, okay, advanced gain process. Now that gives you another gain of 1.9%. Now you are at 109.1, the third graph, the light blue one. Okay. So you started from 98.9, very manual. You upgraded to second upgrade, hardware, a slight hardware upgrade. Now there is you are at middle where everything is automated. Like everything is a machine now. No manual intervention. Okay. Now people like me, an expert, comes says, you know what, I could do AI with you now, and let's put AI here. Okay. Let's put some AI here. The process of maybe applying the chain or anything, there are few processes which AI could help you in this. Let's put AI here. So now that's directly giving an AI automation, you give a 6.5% gain in your profit. That's an amazing feat, right? Just by putting simple AI algorithms, you now have a 6.5% increase in your profit. Your gain is 6.5% now. Okay. And now then you do then there is something called continuous learning. You are improving your AI, improving your processes. AI is learning continuously, AI is improving. That gives you another 2.8% of the gain. Now you are at 118.7. So you started from 98.9 in the left. Now you gone to 118.7. That's amazing feat, right? Now starting from back and now coming at here. That's a lot of difference from where you started. So that's the power of AI, guys. You can start from a very basic step and you can gain so much using AI and automation. Okay. You can see the gains AI is giving you so easily. That's the process of applying. That's the life cycle every industry has to go when they're applying AI in the manufacturing industry, right? Now let's discuss where it can actually give you. You can use AI in manufacturing industry, right? You can use for predictive maintenance. What is predictive maintenance? You actually try to predict that, okay, you know what, you can predict, okay, this part will fail, this part will not fail. If I this is my if let's say I give an example. I like to give a lot of examples, right? There is no point of learning without examples, right? So predictive maintenance is nothing but, let's say I am getting a lot of sensor data. Okay, I have this machine which is giving me a lot of data about sensors. I take all this data and I try to predict the failure of this machine using this data. That's predictive maintenance. You try to predict the failures of your machine using this particular predictive maintenance. safer operational environment. As I said, the moment AI comes up, the task like filling the buckets, which where humans used need to go there, now humans need to be there. So it's called safer operational development. Now, where the where humans are, it's very dangerous for humans to work. AI could go and just do those tasks which humans were doing, and it's a very safe environment now. The machines could do that for you. Human robot collaboration, right? So now, since we have robots as a part of AI, humans and robots can work together to solve problems. That's also very people. That's also what people do in AI in industry. Quality 4.0. So quality checks are very important for Indian industry, right? So these days, most of the quality checks are done by humans, but now some people are using AI for quality checks as well. AI is reading their product and see the quality as well. That's also possible. Cost optimization, yes. Using AI, people are able to optimize their costs. Algorithm is telling them, you know what, you have to do this, you have to do this, and your cost will decrease. That's possible of AI cost optimization. Digital twins. Digital twins is nothing but you are actually digitally you are able to replicate the task easily. You are able to replicate task one and task two using digital twins. So these are some of the areas where AI is getting used in industries. Obviously, there are more to it, but these are the very common ones. Okay. All right, but let's discuss the current scenario right now, where we are in 2019 and 2020, and where we were in 2019, and where it could be in next 8 years as far as the AI in manufacturing industry goes. Okay, so first of all, North America is taking the most market share right now. Around 90% is happening of AI in manufacturing is happening. The artificial intelligence is happening in North America. After that, 40 to 50% is happening in Europe, Asia Pacific, which is Singapore, India, China, Asia Pacific. This is around 50%. And then the rest of the world is pretty less. So three major players are North America, Europe, and Asia Pacific. Okay. These are the major markets of AI in industry right now. Let's talk about top companies. So top companies are Microsoft. We all know about Microsoft. They are using a lot of AI in their automation. They are manufacturing PlayStations, laptops, Microsoft tabs, etc., etc. And they are using a lot of AI in their automation. There is a great company called Rockwell Automation, Cisco. Cisco Systems is a networking company using a lot of AI in automation. Alphabet is the company behind Google. Alphabet Inc. is the parent company of the Google. Okay, these are the key top companies in the region right now. Then there's a concept let's discuss about on-premise and cloud. What is on-premise and cloud? The third graph, the bottom left. There are two ways, right? When you have to use AI, you have to use a lot of computers, right? You have to use a lot of machine power. So there are two ways to do it. There's something called on-premise that, okay, I buy my own set of computers, I connect them together, I create my own server and everything. I host in my local, right? So let's say if your college is actually using a lot of computers and they are using their own server, they're using everything in their local, they're setting up their whole thing uh, in the college itself. That's called on-premise, that your everything is with you only. It's physically, you can see it and you can see that. Cloud is something that you are using someone else's computer. So cloud computing is very, very booming these days. Every industry is going to cloud computing. And you can see right now in 2018, 60% was on-premise and 30% was cloud. But in the coming years, it's bound to increase. And then you can see then what's the ratio of hardware and software of AI. So you see hardware is only 20% of AI. Software is actually around 80%. That's the scenario in 2018, and that's the scenario in 2027 as well. That's pretty clear right now. So we can see easily that hardware is a less amount of that. Major of that is software. Major of that is computers and writing algorithms. Now let's talk about the skills that are needed to do in AI industry. Let's talk about that. Actually, let's talk about yes. So actually, if you have to do AI industry, excuse me, just need some more water. Yeah. Skills needed to do in AI industry, right? So as I said, AI is a very, very broad term. It's a very huge concept, but you can do a lot of stuff with AI. And there are a lot of what do you say? You are a lot of stuff that comes with AI. There are a lot of skills and roles that come with AI. There is something called process and automation engineers, which are nothing but the process data and automation know-how. So these people are basically people from mechanical industry, the people who are already working in the manufacturing industry. These people tell us that, this is the process. These people tell us that, okay, this is the process that we are following. This is how the machines are working. The automation, they know the actual process. Then people like me come. We are the data scientists. What we do is that we understand the problems from the process and automation engineers, and we just say that, okay, this is the process. Okay, now let me see what can I do. How can I do AI in this? Then there is IT and data engineers. So these people are the IT people. They set up the IT infrastructure. They get the data for me. They get the data and everything for me in the place, etc., etc. These are IT engineers. Then there's AI creation experts. So these are the people that may not to be an expert in AI, but they help in creation of the AI. They help me in the training of the algorithms. They help me in the capturing of this data and everything, etc. These are four major roles that come up. Okay. And you can see this, these connect together. Data science is what I do. IT and data people are also there. Their job is to set up the computers and do the IT for me, get the data for me, write the programs calling the data for me. AI creation training are the people that that help me in this process. These are people I give them the simple task of training the data and simple tasks. And then obviously there's a process automation people. These people are the mechanical people who are telling me that, okay, this is the problem we are trying to solve. How can you do AI in this? So skills may need to be developed to create in-house AI. So there are a lot of skills that are required. So there are a lot of things that yeah, when you have to do AI, you need these four types of people for sure. Okay, let's talk about effect of AI on industries. Okay, very important. So why AI is important these days, right? So there are multiple industries we can talk about. We can talk about business services, finance and insurance, manufacturing is what we are discussing today, education, health and social services, other services, in INC, information and communication, construction, transportation, wholesale, utilities, etc., etc. All right. So if you talk about, you know, let's see which one is doing the best right now. If you see finance and insurance, right? That is, if we don't, it's going to, first of all, this is a future forecast. Okay, this is how the growth of industries are looking for next 5 to 10 years. Okay, if you talk about insurance and finance and insurance, it's bound to go by 46.8%. Sorry, 12.8%. That's the scenario right now. But if you want to go beyond that, if you don't use AI, that you are just at 112, right? The second bar graph, the finance and insurance. But if you want to go 46.8% more, you need to use AI. If you don't use AI, you're limiting yourself to 46.8%. That's a lot number. That's a huge number, right? For $1 million business, if you cannot if you don't use AI, you are using that much. Even in manufacturing, if you don't use AI, you are using 32.8% of growth, which is a tremendous growth. If you don't use AI, losing 32.8% is a huge number to lose, right? So that's why we are talking today. AI is so important, right? If you don't use AI, you are losing that much amount of growth, which is not good, right? 32.8% is a growth. It's a great growth for any business. Even a single digit growth is great for any business, and now you are using double digit and that to 32%. Amazing growth. That's the power of AI, guys. Same scenario is happening with the others as well. Education can lose 20.8% without AI. Business services can lose 40 to 45% of their growth without AI, which is not good, right? It is very bad. So understand, right? That if you don't use AI, you can lose so much of the growth. Manufacturing with AI, right? This is a very simple example when AI can help you, right? I've been talking about AI. This is not a very clear picture, but the idea is that an AI is able to recognize the objects in this image. So you can see chair is getting recognized, a person is getting recognized, and we see these boxes around, rectangles around this. This is AI, right? AI is able to see the image and tell you that, okay, this is a chair, this is a person, that's something else, that's something else. That's how AI is used in industry. That's a very basic example of how AI can be used in industries, right? Manufacturing industry. Manufacturing, you can give it an image, AI will tell you that that's an image, that's a person, that's a chair, etc., etc. This is a very broad example. I put this slide to give you a picture because I've been talking without pictures. This is how AI can be used in industry. This is one example. Okay, identify objects in an image. Very, very important, right? But is learning ML enough? Just the machine learning? No. To actually do some meaningful projects with ML, just learning ML is not enough, guys. Yes, there are other lot of skills. These are mostly software skills, but I wanted to put this here because I wanted to give you guys a very whole picture that just learning machine learning is not enough. If you want to do AI in your career, if you want to do machine learning in your career, just learning ML is not enough. You have to learn cloud, GPU computing, coding skills, etc., etc. There are a lot of skills that come with AI apart from just learning machine learning. There are other stuffs that are very, very important while you are machine learning. So it's important to learn all these related skills, guys. Okay. So I'll pause if you have any questions, and then I'll continue for the rest of the session. Do we have any questions right now? Can anyone help? I cannot see this. Like, anyone help me if we have any questions? Anyone?
Participants, I request if you have any questions, please post it on the chat box. We will take up the questions. You're also free to unmute and you can ask your questions. So there is, Mr. Umang, there is one question that I'm taking from YouTube.
Sure.
Yeah, Mr. Michael, he's asking whether AI is suitable for all industries.
The answer is yes. As I said earlier, AI is something that every industry has the potential to use AI. You just have to define the problem well. Obviously, if you are able to differentiate between the rules and the other, if you are able to differentiate the problem with an AI problem with a non-AI problem, yes, every industry has the potential. I have been able to apply industry in manufacturing, power, insurance, finance, retail, multiple industries.
Okay,
That's
thank you. So there is one more question from Mr. Dennis. He is asking, what is the first step in terms of learning or upgrading the skills to work in a manufacturing industry which uses AI or ML?
I think it depends. So if you want to learn AI, I think the first thing you should learn is coding. Python is very important. So Python is the most common language of doing AI. So first step of learning or upgrading skills to do AI, no matter which industry you are in, is to actually learn Python. And then you can definitely learn machine learning, but you need to learn coding for sure. That's very important. That's the first thing to understand, and then you can learn the related skills as well, right?
Yeah,
Your Python is done, your machine learning is done, and then you can proceed with it.
thank you. So I think there is a question from Mr. Prasad, and he's asking regarding the hardware that are being used in the industries which are using AI. So what kind of hardware are being used?
It depends. So when you are training machine learning algorithms, it requires a lot of compute power. So we use CPUs, GPUs basically. Majorly we use something called GPUs or the graphic card. So the graphic processing units, the GPUs, they are used for the training of the algorithms, and they are very important. So GPUs and good amount of CPUs, it's very important for using AI. Okay.
Okay. Yeah.
All right.
Thank you so
So
much.
I think, yeah, do we have more questions?
Yeah, I think you can continue. Probably in the end, we may take few
Right,
questions.
right.
Yeah,
Yeah, that's
yeah,
what I was
yeah,
going to
yeah,
say. Let's do it in the end. I just wanted to take a pause to take few questions, and
yeah.
rest of them I'll take after the
Okay.
session. Yeah, I'll answer all of them for sure. That's a promise. All right. So we're there. That's where we were. Yes. So next slide, we're actually talking about how to learn AI. So that will answer a lot of questions that people were asking us a while back. Approach to learn AI. Start with basics of Python. That's very important that you learn the basics of Python. That's where everyone should start. Then you start with the basic ML algorithms. Okay, so basic ML algorithms mean there are some statistical algorithms to learn ML. So that's very important. So these are the basic ML algorithms. That's the second step for you. Third step for you, once you are done with your Python, you are done with your basics and machine learning algorithms. Then you proceed to do the related skills such as cloud, Spark, etc. So you will know once you reach there, you will automatically you will make your path there. So but you have to do the first two steps properly. Third step you will learn easily. You will get there. I mean that's not a problem. But then you have to start deep learning. Deep learning is the most common, uh, most important area of AI these days. I personally my expertise is in deep learning only. That's my forte. I do deep learning a lot. Deep learning is the most sophisticated and most efficient AI possible. It works the best. Let's see a demo actually. I've been talking for a long time now. Let me show you a machine learning demo right away. All right. So I'll be playing a game with AI today. Okay. This is a very common game called Pac-Man. Pac-Man is nothing. This guy, this yellow guy, this is a very common, very famous arcade game called Pac-Man. It's a very simple game. This guy will actually just move around this particular arcade game, and you have to get all these, eat all these to get more points. And these bad guys will try to eat him. Okay, the moment these guys see him, they will eat him. Okay, but how do I play it? Okay, I won't be playing it via keyboard. I'll be playing with via my video feed with my images. Let me tell you how. If I let me give you give some samples to the program, and it will the AI, and I'll play the game using my gestures. Okay, so if I do this like an upward fingers, let me add a sample here. If I do this, the AI the Pac-Man should go up. If I do this, let me add a sample here. The Pac-Man should go left, and if I go this, the Pac-Man should go down. If I do this, the Pac-Man should go right. Okay, so I gave 4 commands to Pac-Man on my camera, that you can see: up, left, down, and right. Okay, and let me train the model. Okay, training the model is basically how the AI is learning. It's learning right now. It's learning, and it's getting trained. The training is done. Let's play now. Let's see how these gestures will come. So you get the idea. I give it 4 samples of images that this is how I'll. If I do this, it should go. Pac-Man should go up. The Pac-Man should go up, left, right, depending on the action I'm doing. So let me start by doing a action for left. So yeah, it's ready. Let me start by doing an action for left. Then if you could see, let's go up. Let's try to go up. See what's happening? It's going up. Then it's going down. Let's go left, up again. You see the Pac-Man is moving depending on my gesture. Yes, let's try to go up again. Let's try to go up again, and then now the Pac-Man is dead. Let me just try one more play. Okay, let's say it's ready. Let it start. Yep, ready. Come on, Pac-Man, start. Yeah, started now. Yeah, so it's. Let me go up again. Yeah, you see it's so easy, right? The Pac-Man is string my command. So you see the AI is so simple, right? I just gave it 4 samples, and the Pac-Man is just able to recognize my samples and play the game with it. Obviously, I can give it more samples; it would work better. But you get the idea, right? Pac-Man is still taking my samples. For example, it's still thinking that I am doing a left or right. See if I give it again. If I give this again. Yeah, Pac-Man is going up now, and then I can just do a right as well. It's easy, right? So you see what's happening, right? The Pac-Man is able to understand my gestures, my direction, and now it's dead. Simple AI, right? 4 images, learn the AI, and we are good. Easy, right? That's the power of AI, guys. And industry has so many uses of this, right? Industries can just use it directly and just they're good with it. Let's go back to the slide. That was the demo, ML demo. Now let's talk about so that was simple, by the way, the demo, right? And let me talk about, how did I do it? This was simple. This was all happening in my browser. This particular simple AI did not require a lot of hardware. I mean, yes, the training required some hardware, but that's about it. This particular AI was simple, right? It's very simple. You give it the images and it's able to run its algorithms easily. Simple, right? That was easy, right? So, and that was just happening in my browser. That's how happening in my local browser. No sophisticated machine hardware required for it, for the application to run. For training, yes, you need a GPU and everything. For training, you don't need any of that. Okay. Risk behind AI projects, very important, right? AI projects has their own set of risks, which is very, very important, right? Because AI projects are prone to risk. There's data difficulties for sure. So when I say data difficulties, I mean, stuff like, how do I say data difficulties? Data difficulties are the problems that every industry face. Data difficulties means the industry don't have enough data to actually train that. That's happening. That happens with almost every problem that we try to solve. That they don't have enough data to train their machine learning on, which is a problem, right? You want to have the enough data to machine learning for machine learning to train on. Data difficulties do arise. Yes, they happen a lot. So it's very important to understand data difficulties. That's the first risk that can come, that you don't have enough data. You have a problem defined, you have your budget for AI assigned, you okay to take the risk, you are AI experts. Now the data is not there. Biggest issue. Second issue, the risk that can come is the technology troubles. Yes. So what happens is that even though your data is fixed now, let's assume your data is good now, technology troubles may occur. When I say what is technology trouble, you can say that your your IT engineers, they are not able to do, they are facing technical issues while setting up your IT for this. Your machines are not there, your technology is not working, something else is breaking, technology is always come with set of issues. Tech troubles can come up. Security snacks, yes, that happens a lot. That even your data is fine, your technology is sorted, but now security snacks can come up. Security snacks means your data protection, right? So data come with its own set of issues, right? Data has got privacy issues. You have to maintain the privacy of the users. You have to maintain stuff like that. You have to, maintain the integrity of the users. Your data should not be leaked. You have to maintain about data privacy. Facebook and Google were facing this issue about data privacy recently. The security snacks can come up. Security is very important. Models misbehaving, yes, that's also possible. It's very much possible that you trained your model properly, but it's possible that their model is not behaving properly, model is not, working properly, it's giving some very, very bad results. So there's a small risk of that as well. Interaction issues, very much possible that human computer interaction is happening with your AI, and AI is not able to interact with human properly. It's not able to get the commands properly, it's not able to learn properly, etc., etc. Those are interaction issues. Making AI bias free. So what is bias? First of all, let's discuss that first. What can happen at times is that your AI, first of all, what is bias, right? What happens at a lot of times is that your AI algorithms get some sort of bias. Okay, I'll tell you what kind of bias that can exist. Okay, let's say talking about going to our previous example of going to, this one, your bucket which is getting filled with the tablets. The tablets are getting filled in the bucket. Um, I say, let's say I train my machine learning algorithm only on red buckets. Okay, I only train for red buckets. Okay, I only train the algorithm for red buckets. But I did not take into encounter the other sort of buckets that can come. Okay, the buckets, the white bucket or black bucket or blue bucket, that are also possible. But I did not train for them. My AI is only trained for red bucket. What may happen, I'm not sure it will happen. What may happen is that since the AI is only trained for red buckets, not the black or blue ones, what may happen is that the AI fails for other colors of buckets. There is already a bias. It's biased only towards the red buckets. It's not working for black or blue or white buckets. It could be possible. It could happen. That's the bias, right? That's the kind of bias that can occur. Then there is a bias of people as well, right? So there was a store in America who actually trained only for white people. They trained the facial recognition system, that they have the system that people will just show their face on the machine, and they'll just go with it. Okay, the gate will unlock with the face. Okay, so what they did is they only trained on white people. They did not train on black people. Unfortunately, the machine did not work on black people. That's another bias. That's a racial bias. Racism is very, very bad. And now your AI is doing racism, that's even more bad. So it becomes our responsibility as AI experts that we make sure that uh, we make sure that our AI is bias free. So first of all, be wary of the inputs, that your input, whatever the input data that you are giving to the machine, it's very important. There should not be any bias. You should give all sorts of inputs. All you want, it's you want to take the buckets, for example, you have to give it all sorts of buckets, all colors of buckets. Make sure, open up the black box. Some people say AI is the black box, But if you're an AI expert, you are a good AI data scientist. If you are good enough, you will know what's happening under the black box. So you have to know what's happening inside that. You have to be very clear about it. You have to be very open about it. You know what's happening inside. If you don't know what's happening inside, it will be out of your control. There is no magic bullet to it. You have to just be very careful while building AI that you don't occur any bias. That's very, very important. So there is no magic bullet to it. And obviously keep learning. You keep on giving it new data. You keep on giving it better and better inputs. You make sure everything is happening correctly. You are improving. That's how you make AI bias free. That was the end of the session, guys. That was the end of the session from my side. Let's take questions now. I'm happy to take any all questions now. Okay. Hello, can you guys hear me?
Yeah, I can hear you, sir.
Yes. So I'll take some questions now.
Okay.
Yes.
So I request the participants, you can unmute and you can interact with the speaker. If you have any questions, please, or you can post your questions also in the chat box. We'll take up the questions.
Yeah, so I'll take some questions from the chat now. So I see I'm a final year graduate student. How to get into industry being an AI integral part of? Yes. So I would say it depends. That's the question from Say. Okay. So it depends actually. If you want to be a mechanical engineer or an AI engineer, you have to set up that difference first. That's very important. Uh, first, if you want to become an AI engineer, then there was a slide for that. You have to learn Python, you have to learn machine learning, then you can get into it. The other option that you could do is that you can take a mechanical engineering job now, learn about mechanical engineering properly, learn about industry properly, and then at the later point of time you learn AI and then switch to do AI in industry now. So there are multiple paths to this. You become an industry expert first, then AI expert. That's even better. Or you can become an AI expert right now and just directly do AI. That's also possible. So it depends on which path you want to take. Both of them are possible. Which programming language you want must learn? Python anytime. Python is very, very important. That's the first language you should learn. Hardware I already told. Okay. And then, all right. Without computer application and hardware like machinery equipment, can AI exist? No, it cannot exist. Computer is very, very important. AI is all coding. AI is all machine learning, and AI is all computer science only. It depends on computer science. So without any sort of coding, without any sort of machines, computers, or hardware, no machine cannot AI cannot exist. All right. Is it necessary to learn AI for mechanical designers and engineers? What would the scope? I would say definitely not necessary. Definitely not necessary. It's nothing is necessary. If you are a mechanical engineer, it's not necessary to learn AI. We have AI experts for that. But if you want to learn, then obviously its world is an open place. But I would say designers and engineers don't need to learn AI. They're AI experts for that. You want to learn for your interest, you can. You want to explore that area, that's up to you. But it's not necessarily at all. No, for mechanical people, it's not. But if you want to learn, if you want to switch your career, you want to become an AI expert, then obviously you can learn. That's up to you. Scope is enormous. You can learn anything you want, and AI is the hottest field right now. Data scientist is the hottest uh, job of the 21st century. So definitely, it's there. You should. The scope is enormous. There is no limit for that. Certified course or training program in India for AI. There are a lot of certified courses and certified courses and AI programs that are running in India. But I suggest you don't really need to take the certificate courses for sure. For sure, you don't need them. I'll tell you why. Everything is in their internet for free, so you can pretty much learn all the AI, the courses, the books, and everything is open source on internet. So you don't really need to go for any program or any paid program per se. Everything is there on internet. Just you make use of internet. You don't need to spend 5 lakh, 10 lakh worth of rupees for these courses. Certifications don't hold any value in industry. When we interview people, we don't ask for certificates. We don't really care about anyone's certifications in AI. Okay. Can you mention some project ideas for B students and PhD aspirants? Project ideas can be many actually. You can make a self-driving for let me give you an idea about mechanical engineers only, some ideas on mechanical engineers. For BE students, you can make self-driving car, small self-driving car. You can take a Arduino Uno or a Raspberry Pi, and you can train it to drive itself. That's a very simple concept idea where you can combine mechanical engineering with AI. You can make a people counter using Raspberry Pi. You can automate a machine using AI. So there are a lot of possible uh, possible concepts that project ideas for machine PE students and PhD aspirants that you can directly use and try. Self-driving car, self-driving machines, self-driving boats, self-driving planes. These are the most common ones these days. For PhD as well, people have done their PhDs in these areas, so you can try that out. Can a mechanical industry engineer enter into gaming industry? Um, I think it depends actually what kind of gaming you are saying. Software gaming is the most common one, and gaming is a very big industry. If you want to get into gaming industry, anything is possible, but you have to learn a lot of coding, then etc. etc. Or you can be in the mechanical part of it. You can be in developing these hardware for these games. You can develop the joysticks, the Kinect, all that hardware that's required for playing games. You can be in that part as well. Which platform is used by industry for AI and ML? Depends on platform. What do you mean by platform? So we use cloud platforms usually, and we use, if you were talking about operating system, Linux is the most common one. Windows some people use, but most common one is Linux, Unix, and Mac. And yeah, I think that's the
I had one doubt.
yeah. Please go ahead.
Just last night, I was watching a documentary on Netflix on the name it goes by the name Social Dilemma. So the
Yeah.
documentary tells about how like social media invests a huge amount, an enormous amount to keep keep their users invested in the amount in the app using AI and machine learning. So I wanted to know if there is any prospect of regulating this, since it's a huge risk to the Gen Z, to the younger generation, because they are attached to their screens all the time. So is there a way of regulating that and making social media a safer space, and to regulate all the AI and machine learning which goes into the social media apps?
I'll tell you what. So the whole idea that I want to give is that companies, the social media platforms, they are here to engage you. You cannot blame them for that. That's their business. More the engagement the people will be doing in their platform, more money they will make. It's true for any social media there. So algorithms are definitely designed, to keep you engaged. That's their business. You can take any application, for example, and you will see that you will keep on getting new and new videos, new and new reels, stories to keep you engaged, to keep you going. I'd say these are very big companies, and they definitely protect your data properly, so that you can be assured that the data won't be used bad. I mean, the data won't be sold to anyone. You can assume that these companies are good that way. But I mean, you cannot stop people from doing business, right? You cannot tell that you cannot make your content engaging. That's not possible, and no one can say that to anyone. But I think for the people to understand is that the social media is there to take your time. They are designed to take your time. You need to make sure that you don't end up falling in that trap every day. We all do. We all waste time on social media. That's a very common problem these days. But we need to stop doing that. We need to be very careful about that. That's the suggestion I have for anyone. That's for up to us. I mean, these people will do whatever they want, but we have to be very sure that we don't spend hours and hours in the endless trap of social media. That's what we need to do. Okay. All right. So which type of project can we complete on AI and MTech machine learning design specialization? I'd say I think in machine design specialization there are a lot of possibilities that we can start on. But I'd say start with IoT, simple Raspberry Pi or something, and you can think of a people counter, you can think of a cloud counter, etc., etc. So these you can use AI for simple. You can put a camera on your machine and or a sensor on your machine. You can use sensor data to actually track a lot of AI. Okay. And there is a question: what is machine language of AI? So Python, I told, is the most common language of AI. On machine, I think everything goes to assembly language. So usually behind Python, C is running, C language is running. That is converting your Python code into the machine assembly level code. So C is the machine language, if that's what you're asking. Okay.
Yeah.
Another sets used to train AI are fair and balanced. There have been many incidents where AI has seriously made some offense. Like there was a black man who was holding a banana, and AI registered it as a black man holding a pistol. So, how do you think the data sets used to train AI can be fair and balanced
That's what I
in
talked about.
unpredictable situations like that?
Sure, sure. That's what I talked about in my last slide. That's what the whole idea of last slide, that how do I make my AI bias free? That's what I talked about in the last slide. So, as I said, there are four key points to it. First of all, be wary of the inputs that you are giving to the model. It should be balanced. You have to make sure you are giving all types of inputs. You are giving white people's images, black people images, in brown people images, all of these images. It's very important to be careful of the inputs. You should be know about what's happening in your algorithm, the black box that's happening behind AI. The third point is that you have to keep continuously learning, and there is no magic bullet to it. That's the fourth point. So if you are very careful about these 4 points, you can make your AI bias free. That's the whole recommendation for making AI bias free. Okay. Yeah.
Yeah,
Any
Mr.
other?
Umang,
Yeah.
this is Prashant speaking. I'm the coordinator of this particular
Yes.
session.
Yes.
Yeah.
Yeah.
So it was a very nice, session, an overview of artificial intelligence, and you have given a lot of, uh, insights into the application of AI in manufacturing, which I believe it would be. It was very interesting because since most of our participants probably are from the background of mechanical engineering. So I have a question regarding this AI. What is the most challenging problems that AI is still unable to solve? So,
Okay.
yeah.
So there are a lot of there are a lot of such problems that we are still struggling with. I think the most common one and the hottest one right now is self-driving cars. People have been trying to make self-driving cars since 2012, 2013, and that's a very huge AI problem. But it's still not at the part that you can just tell a car to run, wherever it wants. People have been improving a lot. The autonomous vehicle, the self-driving cars are improving a lot, but it's not still at the point where you can just ask a car and say it and it will drive itself. So self-driving car is the biggest challenge right now. One of the biggest challenge. I'm not saying it's the only one. Self-driving car is a very big challenge right now, and there are a lot of these actually. Self-driving car is there. Then there is space tech also. In space tech also, people are trying to use AI in spaceships also. Space shuttles also, people are trying to use AI. So I think self-driving cars, space tech is there, and then people are trying to make self-driving planes as well, and then self-driving by boats as well. So these areas still face a lot of challenge in terms of AI. And then you could say that your translation is still. So I would say almost every area that is there has the capability to improve. For example, Google Translate, the translation, that's also an AI problem. We are continuously improving on that. There are so many models that we've used in translation. People are improving on that. So translation still has a long way to go. Machine translation is still a tough problem to solve. And then there is audio problems are also there. The speaking, you are speaking to AI, it's not able to recognize your words properly. Your Siri, your Google Assistant, you are not able to assign, is not able to, read your words properly. So these kind of problems, challenges are still existing in AI, and there are a lot of scope to improve in these. These are still very big challenges for us.
Yeah, thank you. So there are a lot of talk in the industries regarding the maybe introduction of AI, how it may create unemployment to very large sectors of industries. So what do you think? What are your views on implications of AI with respect to the unemployment, or what are the skills that one should inculcate in order to ensure that their jobs, or their jobs are secure. in future?
Sure. So I think I get this question almost every session I give. So the simple answer for this is that AI can and will take your job if you don't take on AI. So the very important thing to understand is that yes, it's very much possible the automation and AI will take a lot of jobs in industries. It's happening right now. People are automating so many things. So if you want to if you don't want to be the person who can lose his industry job because of AI, I suggest you learn AI. You learn basics of Python, you learn basics of AI, or you learn basics of programming at least. That's important. Or you want to be a very, very skilled person in terms of designing and stuff, right? So, for example, mechanical designing, car designing, or equipment designing is something that cannot be automated by AI. It's still a designer has to do it. And we are still far, far from a point that AI can design your machine, right? So, designing, creative part, and doing the engineering behind it, and connecting those parts together, making this whole car work, making the whole machine work, these are very, very niche skills, right? So just ask yourself this question: if you're in a industry job, if you think it's a very simple job, right, like automating the production pipeline, right? For example, a guy who's just putting a screw on a machine in a car, the whole job is to put a screw. That is a very automatable job, right? Anyone can automate that easily. So ask yourself this question, right? The simple manual jobs which does not require a lot of skills, yes, they can be automated. So make sure you are not in these skills which are very manual and do not require a lot of mind to use. Those kind of skills can be automated very easily and will be automated in the near future. So be in the very, very niche areas, very skilled areas where very skilled people are are taking their position. That's how you can survive the AI right now. Yeah.
Yeah, thank you, Mr. Umang, for that elaborate answer. So I believe we have taken up almost all the questions. We have actually compiled the questions from YouTube also, and then we have posted it in the Google Meet. So we have taken all the questions. Still, if there are any questions, I request the participants, you can get back to us. You have your email ID, so you can just post us your queries. We will try to reach out to the resource persons, and try to get your answers for those questions. So with that, now I would like to extend my warm gratitude and thanks to Mr. Umang for delivering that insightful lecture on artificial intelligence. So thank you very much, sir. Thank you for that excellent session. I would request the participants to kindly access the link that has been posted in the chat box to provide us your feedback. And I request all the participants to kindly join us for the afternoon session. Just to brief you, we will be having a session on connected systems. So it's basically about smart manufacturing perspective with respect to Industry 4.0. So I request all the participants to kindly join us back for the afternoon session at 2 o'clock. And I'd like to also thank SpeakEd for also helping us in organizing this particular event. So with that, I would like to thank one and all. Thank you for all the participants for joining us, and let us get back. Let us meet each other in the afternoon session, right? So thank you one and all.
Yep, thank you, everyone. It was a great session. Thank you for joining.
Thank you. Saravanan.
Hello.
Hello. Yes, sir.
Sir, I have two questions, sir. Prasad, sir.
Sir, you can let us know your questions, sir. We will try to get the questions.
No, sir, about this meeting, not to Mr. Umang, sir.
Okay. Tell me, sir.
I will ask you, sir. In that feedback form, sir, there is one ID, participant ID. Just we write that ID number.
Correct.
That's all, or we will write the total?
No. Only 3 last digits you write, sir. That's more than.
Okay. If I have 1, 2, 3 means 1, 2, 3.
Correct. That's all.
Okay, sir. Afternoon session, sir, 2:30.
2 o'clock we will be having sessions. 2 o'clock to 3:30. 2 to 3
Okay, sir.
seconds.
The same ID.
Same link.
Meeting.
Yeah.
Okay, sir. Thank you. Thank you very much.
Thank you.